we now have not only unprecedented views of its surface, but a whole new tour of the moon that shows how both it...
Did you know that a group of English monks witnessed the moon explode 800 years ago? According to their account, the upper horn of the moon suddenly split apart, unleashing a burning torch that flung flames, coals, and sparks across the sky, while the moon itself seemed to writhe and tremble like a snake struck by a staff. This eerie, poetic description, recorded by Gervase of Canterbury, has long been dismissed as either metaphorical or misunderstood, but centuries later it would spark an astonishing theory that these monks may have actually witnessed something real and huge. So what was it really? Today, we'll answer just that. Historical background. On the evening of June 18th, 1178, shortly after sunset, a group of monks in Canterbury, England, witnessed what would become one of the most puzzling astronomical events recorded in the medieval period. The observation was documented by Gervase of Canterbury, a Benedictine monk and chronicler at Christ Church Cathedral Priory. His account stands out in the annals of medieval European history for its vivid detail and unusual content. At a time when the scientific method as we know it had not yet emerged, and astronomical knowledge was rooted more in religious and philosophical traditions than in empirical observation, the monk's description of the lunar phenomenon was exceptional.
It's like much of the high desert of the United States.
They claimed to have seen the upper horn of the newly visible moon split apart, producing a burning torch that emitted fire, hot coals, and sparks into the sky. The moon itself, they said, seemed to writhe and convulse before returning to normal. Witnessed by at least 5 individuals, this event was preserved with unusual clarity and specificity. The monk's observation took place during a very narrow time window when the new moon would have just become visible shortly after sunset. This positions the crescent moon low on the western horizon, providing a specific atmospheric and visual context for the sighting. Gervase's recording of the event is critical not only because of its detail, but also because it situates the observation precisely within a historical and geographical framework. Canterbury, at the time, was an important ecclesiastical centre in England, home to the Archbishop of Canterbury and a major religious community. The chronicling of natural phenomena by monastic scribes was not uncommon, but reports with this level of descriptive richness were rare. Gervase's record would remain largely an oddity in medieval literature until centuries later, when scholars revisited it with the tools of modern science. Before we move any further with explanations, let's see what those monks actually saw. The extraordinary event. On the evening of June 18th, 1178, just after sunset, the sky was clear, and the new moon, having just become visible, hung low in the western sky with its horns pointed eastward, as is typical during this lunar phase. Among the observers was Gervase of Canterbury, a monk and chronicler at Christ Church Cathedral Priory, who would later describe the scene with vivid and almost poetic intensity. According to his account, at least 5 men sitting outside the monastery looked up and saw the upper horn of the crescent moon suddenly split apart. From the rupture, a bright, fiery form burst forth, described as a burning torch, which flung out flames, glowing embers, and sparks with violent energy. What followed was even more startling. The monks reported that the lower part of the moon's body began to twist and move as though it were alive, convulsing and writhing like a snake that had been struck. This trembling or palpitating motion continued for a short time before the moon returned to its previous, undisturbed state. The entire sequence unfolded over a matter of minutes, but the emotional impact on the witnesses was profound. Gervase, writing with the earnestness and reverence typical of medieval chroniclers, conveyed not only the physical details of the event, but also the atmosphere of awe and fear that surrounded it. To the monks, devout men whose worldview was deeply rooted in Christian cosmology, the apparent rupture and convulsion of the moon may have seemed like a divine omen or a supernatural sign of cosmic imbalance. Gervase recorded the event not as someone profoundly moved by what he and his peers saw. In an age where natural events were often interpreted through theological frameworks, the spectacle of a seemingly damaged moon writhing in the sky may have been terrifying. The monks' astonishment and reverence are palpable in the text, as is their uncertainty about what the vision meant. There is no attempt to explain the event scientifically, nor is there a definitive claim of divine intervention. Instead, Gervase preserves the moment exactly as it was experienced: raw, confusing, and unforgettable. Their report has survived for centuries, not only because of its content, but because of the way it captures the sense of wonder, fear, and helplessness that humans have long felt when faced with the unexpected grandeur of the cosmos. Their account offers a rare medieval glimpse into how a group of devout men reacted to what they perceived as a literal shuddering of the heavens. So, what was it actually that they saw? Well, over the years, there have been several explanations. Early interpretation. In the immediate aftermath of the June 18, 1178 lunar event witnessed by the monks of Canterbury, there were no formal scientific efforts to understand what had occurred. Instead, the sighting was largely interpreted within the spiritual and mythological framework of medieval Europe. At the time, the cosmos was viewed through a deeply religious lens, and celestial anomalies were often seen as divine messages or portents of looming catastrophe. The vivid account of the moon splitting, emitting fire, and convulsing would have likely been seen as a warning or a sign of God's displeasure. Given that 1178 fell within a period of social, political, and religious unrest in Europe, including tensions within the English monarchy and ongoing crusades in the Holy Land, it is not difficult to imagine the monks or their contemporaries interpreting the phenomenon as an omen related to earthly events. This tradition of viewing the heavens as a divine billboard for prophecy was not new. Eclipses, comets, and meteor storms were routinely cited as signals of war, famine, plague, or regime change. Medieval chronicles from across Europe are filled with examples of astronomical events being interpreted as supernatural. The Anglo-Saxon Chronicle, for instance, refers to a red crucifix appearing in the sky in 776, interpreted as a sign of divine intervention. Halley's comet, visible during several medieval appearances, was almost always recorded as a harbinger of doom, famously preceding the Norman conquest of England in 1066. In this context, the sighting reported by Gervase of Canterbury would have easily aligned with existing beliefs about the spiritual significance of celestial signs. However, unlike more commonly reported events, such as comets or eclipses, the detailed and specific nature of the 1178 sighting of a seemingly violent disruption on the moon itself was highly unusual. Gervase's reputation as a meticulous and honest recorder of events helped the report survive through the centuries, even as it lay dormant in historical manuscripts for much of the medieval and early modern periods. It wasn't until the 20th century that the event began to attract renewed attention, and with it came a wave of alternative explanations, rooted less in theology and more in speculation, particularly from fringe communities and conspiracy theorists. Some conspiracy theorists have suggested that the moon ejected something that night.
We can clearly see the effects of what is likely the last giant impact event in lunar history,
arguing that the description of fire and sparks emerging from the moon is evidence of some unknown activity or technology. A small but persistent segment of lunar anomaly researchers believes that the moon is not a natural object at all, but rather a constructed or hollow body, possibly of artificial origin. Others have claimed that the event was the result of a hidden military or alien experiment, retroactively projected onto the moon through advanced technology, despite the obvious chronological inconsistency of such a claim in relation to known technological timelines. These theories often appear on forums and websites dedicated to ancient astronaut hypotheses or secret lunar bases, drawing on the monks' poetic imagery to support wild claims. The phrase describing the moon's body palpitating like a pummeled snake is frequently seized upon as evidence of lifelike or mechanical movement, though such interpretations take significant liberties with the original text and ignore atmospheric and observational explanations grounded in astronomy. Mainstream scientists and historians have consistently rejected these conspiracy interpretations. There is no physical or historical evidence to support the notion that the moon exploded or ejected unknown matter in 1128. No corroborating meteor showers, electromagnetic anomalies, or atmospheric disturbances were recorded by other civilizations at the time. Moreover, the moon itself shows no signs of catastrophic restructuring in its geological layers during that period. While the Giordano Bruno crater was once proposed as the result of a 1178 impact, later studies dismissed this theory based on the lack of corresponding global meteoric fallout that would have been inevitable following such a high-energy collision. But in time, experts offered explanations rooted in science. 20th century scientific hypothesis. In 1976, Jack B. Hartung, a geoscientist at the State University of New York at Stony Brook, proposed a striking hypothesis to explain the vivid lunar phenomenon recorded by Gervase of Canterbury in 1178. His theory, published in the respected journal Meteoritics, posited that the monks may have witnessed an actual lunar impact event, the formation of a massive crater on the moon's surface caused by a high-velocity collision with a celestial body. Hartung's work sparked intense debate among planetary scientists and historians, not only because it potentially tied a medieval eyewitness account to a significant astronomical event, but also because it offered a rare instance where a historical text might correspond to a documented geophysical feature, the Giordano Bruno crater. The Giordano Bruno crater is located on the far side of the Moon, at approximately 36 degrees north latitude and 102 degrees east longitude. It measures about 22 kilometers, nearly 14 miles, in diameter, and is notable for its sharp, well-defined rim and its prominent ray system, features that suggest it is geologically young and relatively unweathered by micrometeorite bombardment. Hartung argued that the crater's fresh appearance, especially when compared to nearby lunar formations that exhibit more extensive erosion and smoothing, indicated that it may have formed in the last 1,000 years, potentially aligning it temporally with the 1178 sighting described by Gervase and his fellow monks. According to Hartung, the monks' description of the moon's upper horn splitting and spewing out flames and sparks could represent the Earth-based visual impression of a direct meteoritic impact occurring on the lunar surface. He proposed that the fireball and ejected material from the explosion, combined with atmospheric distortions near the horizon, would have made it appear as if the moon itself was convulsing. This hypothesis gained traction initially due to the unusual specificity and energy of the 1178 account, particularly the use of language like burning torch, coals, sparks, and palpitating like a pummeled snake, all of which could be interpreted as describing the visual effects of a massive impact from the perspective of an observer on Earth. One of the more compelling aspects of Hartung's theory centered on the potential consequences of such an impact. A high-velocity collision large enough to produce a crater of Giordano Bruno's size would have released an enormous amount of energy, equivalent to hundreds of megatons of TNT. According to Hartung's calculations, approximately 10 million tons of lunar debris would have been blasted into space, with a significant fraction of that material escaping the moon's gravity and traveling toward Earth. He estimated that this would result in a global meteor storm as lunar ejecta entered Earth's atmosphere over the following days or weeks. These fragments, possibly up to several centimeters in diameter, would burn up in the atmosphere and create thousands of bright meteors per hour, visible across much of the globe. This predicted meteor storm would have been an unprecedented natural spectacle. Paul Withers, a later researcher at the University of Arizona, performed calculations in support of Hartung's impact model and concluded that the resulting meteor activity would have rivaled or exceeded the peak of the 1966 Leonid meteor storm. Withers estimated that Earth would have experienced around 50,000 meteors per hour for up to a week, a breathtaking light show that would have been impossible to miss in medieval skies. However, despite the theoretical elegance of the impact explanation and the consistency with lunar geological evidence, the model faces a serious challenge. There are no historical records of such a meteor storm occurring around 1178. Neither European, Middle Eastern, Chinese, Korean, nor Japanese astronomical archives, many of which contain meticulous night sky observations, mention any unusually intense meteor activity at that time. This conspicuous silence casts doubt on the idea that such an event took place, especially on a global scale. Furthermore, the position of the Giordano Bruno crater on the Moon's far side presents another problem. In 1178, the far side of the Moon would not have been visible from Earth, meaning that a direct view of the crater's formation would not have been possible from Canterbury or anywhere else on Earth. Some scientists have suggested that perhaps the ejecta plume or the associated flash of the impact could have been visible, but this remains speculative and difficult to test. While Hartung's hypothesis is not universally accepted, its enduring appeal lies in its imaginative synthesis of astronomy, geology, and history. There have been other explanations as well. Counterarguments and scientific challenges. As noted earlier, in 2001, Paul Withers from the University of Arizona's Lunar and Planetary Laboratory published a critical analysis in the journal Meteoritics and Planetary Science, challenging the lunar impact hypothesis proposed by Jack B. Hartung in 1976. Withers carefully evaluated the core claim and raised several scientifically grounded objections. His most pressing concern was the total absence of corroborative evidence for a global meteor storm that should have resulted if a lunar impact of such magnitude had occurred. According to Hartung's model, more than 10 million tons of ejecta would have been launched into space, with a significant portion falling into Earth's atmosphere within days or weeks. This debris would have created an intense meteor storm observable worldwide. Withers emphasized that such a global meteor event would not have gone unnoticed, especially in cultures with established traditions of sky watching and meticulous record-keeping. The Chinese song She Chronicles, the Japanese Meigetsuki, and the Islamic works of astronomers like al-Biruni and Ibn Rushd make no mention of a celestial storm on the scale predicted. European monastic chronicles also fail to mention any unusual meteor activity around June 1178, beyond Gervase of Canterbury's account.
1178, a group of 5 monks in the city of Canterbury.
To explain the monks' report in a way consistent with both the historical record and modern astrophysical understanding, Withers offered an alternative hypothesis. He proposed that what the monks witnessed was not an event on the Moon itself, but rather a terrestrial meteor that happened to align visually with the Moon from their specific vantage point in Canterbury. According to this explanation, a meteor or fireball entered Earth's atmosphere and exploded along a trajectory that intersected the Moon's apparent position in the sky at that moment. This created a vivid optical illusion. It appeared to the monks as though the explosion was occurring directly on or just above the lunar surface. The meteor's bright flare, fragmentation, and trailing debris could account for the reported imagery of flames, coals, and sparks, and the apparent division of the Moon's horn. The description of the Moon palpitating like a pummeled snake may have stemmed from atmospheric turbulence or afterimages caused by the sudden, brilliant flash of the meteor exploding in the sky. This visual overlap, Withers argued, would also explain why only 5 or so monks are known to have observed the phenomenon. The event would only have appeared so striking and aligned with the Moon from a very narrow geographical range. Essentially, those standing at a particular angle in Canterbury at sunset on June 18, 1178. For observers in other parts of the world, or even nearby regions with different viewing angles, the same meteor might have appeared as a bright fireball or meteor streaking across the sky, entirely disconnected from the Moon's location. This theory provides a more coherent explanation of the observational data without requiring the physical restructuring of the lunar surface. Withers' critique and alternative theory highlight the limitations inherent in pre-modern astronomical observations, which lacked the precision tools of modern science and were often filtered through symbolic, religious, or poetic interpretations. It also highlights how human perception is prone to misinterpretation, particularly in the case of rare or unexpected celestial events. The monks of Canterbury, though earnest and observant, were not trained astronomers and had no conceptual framework for understanding atmospheric meteor explosions or the optical illusions they can produce. Nonetheless, the 1178 moon account continues to hold educational value today. It is widely cited in planetary science and astronomy courses as a case study in critical analysis, demonstrating how historical eyewitness reports can be reinterpreted using astrophysical models. and how skepticism and evidence-based reasoning are vital in evaluating seemingly extraordinary claims. To date, the most plausible explanation for the Canterbury sighting remains the atmospheric meteor explosion hypothesis, which aligns more closely with known scientific principles and historical data. While Hartung's lunar impact theory introduced a creative and stimulating possibility, the lack of global meteor storm reports and the moon's far-side crater position make it increasingly untenable. Yet, the cultural significance of the 1178 event endures. It remains one of the most striking medieval accounts of a celestial anomaly, demonstrating how a momentary spectacle in the sky can ripple through centuries of scientific debate, inspiring both imagination and inquiry. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.